NASA says nothing unusual happened during Artemis 2. The astronauts returned safely. The mission was called a success. But weeks later, an internal message began spreading through engineering circles. Something tracked Orion on its journey home from the moon. Not for minutes. For 3 days, 3 independent systems allegedly saw it. NASA has not fully explained it. And according to leaked discussions, whatever it was appeared to adjust its trajectory alongside the spacecraft. If this is real, humanity may not have returned from the moon alone. Everything looked perfect. Artemis 2 launched at 6:24 p.m. Eastern on April 1st, 2026, from Kennedy Space Center's Pad 39B, riding the most powerful rocket NASA has ever flown. 4 astronauts, Reid Wiseman, Victor Glover, Christina Koch, and Jeremy Hansen, were strapped inside the Orion capsule, trusting their lives to a machine designed for the deepest reaches of space. The mission profile was clear: a 10-day journey, a free return loop around the moon, then home. After a flawless translunar injection burn, Orion accelerated past 24,500 miles per hour, arcing toward the moon's far side. The spacecraft passed within 4,066 miles of the lunar surface, lost signal behind the moon, then re-emerged, precisely on schedule. On the return leg, Orion performed a textbook trans-Earth injection, setting a hyperbolic path for home. The crew's voices in the downlink sounded steady. NASA's public feeds showed stable telemetry, crisp navigation data, and routine course corrections. Entry interface velocity was 24,000 to 25,000 miles per hour. Splashdown was in the Pacific, off California. The recovery teams found the capsule intact, the crew healthy. No anomalies appeared in the official logs, no unexplained signals. From launch to splashdown, every milestone checked off, every system green. For the world watching, Artemis 2 was a triumph of engineering and human discipline, a mission where nothing went wrong. The sense of certainty was absolute. On the surface, there was no hint that anything had followed them home. Mid-April brought the first sign of a crack in the surface. A screenshot appeared on a fringe Facebook page, timestamped April 15, 2026. The image showed what looked like a stylized orbital diagram, a dotted line labeled possible external object, shadowing Orion's return arc. The post claimed its source was an anonymous NASA engineer, no name, no credentials, no direct link. It described 3 detection channels: Orion's own optical sensor, a deep space network radar echo, and a faint track from a Hawaiian telescope. The object was said to have appeared 6 hours before Orion's trans-Earth injection burn, then stayed close, within a few kilometers, for the next 72 hours, right up to splashdown. No official statement followed. NASA's Public Affairs Office issued the usual no comment. Journalists and space bloggers filed FOIA requests for tracking logs and onboard telemetry. The requests went unanswered or came back redacted. The alleged screenshots spread quickly, reposted by YouTube channels and fringe forums, but every trail led back to the same low-resolution image and the same faceless claim. For all the noise, there was no verifiable original post, no metadata, no chain of custody. The engineer behind the message remained invisible, a rumor, not a witness. Yet the story gained momentum, feeding on the tension between the perfect public record and the possibility of something unaccounted for, moving in lockstep with Orion across the void. The certainty of the official narrative now stood in quiet opposition to a rumor that refused to fade. Speed in deep space is not a number you can feel. It is a force that erases distance, a velocity that leaves the world behind in minutes. After Artemis the engines finished their final burn near the moon, Orion was already moving at nearly 24,500 miles per hour. That is nearly 7 miles every second, faster than a rifle bullet, fast enough to cross the United States in less than 10 minutes. There is no friction, no air, no sound, just the relentless drift of momentum, locked in by the laws of orbital mechanics. The physics that governs this return is described by the 𝐒𝐴 equation. Velocity depends on the spacecraft's distance from Earth and the shape of its orbit. On the long arc home, Orion's speed increases steadily, pulled by gravity, until it hits the atmosphere at more than 24,000 miles per hour. At that threshold, even a single mile per hour difference, what physicists call delta V, means the difference between a perfect re-entry and missing the planet by thousands of miles. There is no room for drift. A piece of debris, a lost screw, even a fleck of paint released with the tiniest extra push will, over 3 days, drift far from Orion's path. Meters become kilometers, then hundreds of kilometers. Only a twin, launched with impossible precision, could remain close. The numbers are unforgiving. To shadow Orion for 72 hours, an object would need to match its course and speed to within a few centimeters per second. Any deviation, any missed correction, and the gap grows, slowly at first, then unstoppably. In this vacuum, even uncertainty is measured in miles. Mid-course correction 1, MCC1, was not a footnote in Orion's journey. It was a deliberate, calculated burn executed on flight day 9, nudging the spacecraft's velocity by a handful of centimeters per second. In the vacuum between worlds, a correction that small is a wall, not a breeze. The math is merciless. If a passive object, a fragment or a piece of debris, had been drifting near Orion after the trans-Earth injection, MCC1 would have left it behind. The spacecraft's guidance system fired, the capsule's trajectory shifted, and any unpowered companion would have kept coasting straight, the gap widening with every second. Over 3 days, even a difference of just 0.01 kilometers per second, 36 miles per hour, means separation by dozens of kilometers. The probability of a fragment matching Orion's velocity within a few centimeters per second, and then mirroring a mid-course burn at the exact moment, is vanishingly small. Simulations put the odds at less than 1 in 10,000. No catalogued debris, no known mission hardware, no accidental twin could shadow a crewed spacecraft through a maneuver like this. Only active propulsion, an engine, guidance, a plan, could allow an object to cling to Orion's path after MCC1. The physics closes the door on coincidence. What remains is not a drifting shadow, but the unsettling implication that if something kept pace, it was not drifting at all. A physicist reviewing the telemetry put it plainly: a passive fragment would be gone within hours. To follow through a correction burn, you need a pilot. Every possible explanation was placed on the table, each tested against the hard numbers and the silence in the records. First, debris. Orion shed insulation and hardware during flight, but fragments that small would have faded from sensors within hours. Radar cross-section and brightness just do not fit. The next check was the catalog. Every known piece of space junk, every legacy probe, every Apollo relic. None matched the timing or the path. A foreign craft was considered. China's relay satellites and recent lunar missions have the reach, but nothing in public or classified logs shows a craft shadowing Artemis 2. That leaves sensor error. NASA's own documentation lists no anomaly, no correction, no flagged glitch. Each answer, when examined, seems to dissolve. No debris, no catalogued object, no foreign asset, no logged malfunction. The explanations run out before the questions do. 50 years before Orion, Apollo crews stared out at the void and sometimes saw things that defied easy explanation. On Apollo 11, Buzz Aldrin described a bright object pacing their capsule, a glint he later thought might be the Saturn V upper stage, though the tracking data never quite lined up. Apollo 12's launch was struck by lightning twice, flooding the cabin with plasma and leaving strange afterimages across the instruments. During Apollo 17, 3 bright dots and a shower of sparks flickered past the window. Later, declassified files suggested debris, but the crew's words lingered in the transcript like static. Each case ended with a technical note or a shrug, never a definitive answer. The pattern is familiar. An anomaly appears, explanations multiply, then the record closes with a sense of unfinished business. In the silence that follows, uncertainty remains, unclaimed, unresolved, and quietly persistent. The silence lasted longer than expected. NASA's official channels offered no update, no denial, not even a technical clarification. Freedom of Information Act requests for tracking logs and navigation data remain pending, some delayed, others returned with entire pages blacked out. The mission evaluation room's records for the return phase are heavily redacted, with only routine entries released and any mention of unusual sensor readings omitted. The orbital diagram that fueled speculation traces back to a public outreach graphic, not a telemetry plot, its provenance confirmed, its ambiguity left intact. When pressed, the flight director's only statement was procedural. If there had been a second track, it would be in the log. No such entry exists. What remains is an absence of answers, of context, of closure. In that quiet, uncertainty does not fade, it deepens. In deep space, certainty is rare. Today, official records show nothing amiss, yet the unanswered data and the silence that followed still linger. As we reach farther, every unexplained shadow becomes both a warning and an invitation. The universe keeps its secrets. We decide how long we look away,